Today I'm going to introduce our first CHED Talk speaker of the season. CHED stands for CheeseHead Engineering Discussions. CHED Talks are like TED Talks but with a blue cheese twist. Today's speaker is Frank the Cycle Brayton, who's Station Director of the Contracted Assets Group of the Dominion Virginia Power, and has regional oversights of over 7 power generating stations. Take it away, Mr. Brayton.
Thank you, Dylan. Appreciate that introduction. Obviously, today I'm just going to talk a little bit about my path to my career very briefly, and then talk about the power industry in general to give you all an idea of how a career in the power industry, how closely it relates to the type of work you do here in robotics. And people always tell you when you start out a presentation, it's always nice to have something a little bit humorous to engage the audience. So as Dylan mentioned, I have my name here, Frank the Cycle Brayton. There's some meaning to that if you're an engineering nerd, and some years from now, if you are in mechanical engineering or nuclear engineering or maybe aero engineering, you'll take thermodynamics and you'll understand that joke some years from now. So you're welcome. You can laugh at it. Or some of you might Google it now and you'll figure it out because you're smart. But anyway, I think most of you know that I'm Tyler's dad. And for those of you who've been around Tyler for the past 3 or 4 years, you know the kind of moves he busts on the dance floor. And I just want to come out right up front and say that he learned everything he knows from me. Yeah, I work for Dominion, and I work with the business unit, Dominion Generation. And I think probably all of you and your parents know that you write a bill every month to Dominion for your electricity. And you most of you are probably familiar with the guys out on the streets that are doing all the work on the transmission and distribution wires and doing hookups to homes. But that's not the side of the company I'm on. I'm on the side of the company that generates the power and gets it to all the customers. And the Contracted Assets Group that I lead, the 7 stations are 7 stations in the state of Virginia. 4 of them are biomass, 2 are combined cycle, which is a type of gas-fired generation, and I have 1 coal-fired generating station. And they're called contracted assets because most of the power plants that Dominion owns, our own employees operate and maintain those stations. These 7 stations were originally built by other companies. Dominion bought them over the years, and I contract other companies to actually operate and maintain them. So that's why they're called contracted assets. Just a little bit about my progression. You know, all of you have the benefit of the robotics, either just through blue cheese, or maybe you did FLL, maybe involved in other STEM activities. But when I was growing up, those kind of things weren't available. And the only reason I initially took the path I did to engineering is because I had a junior high school aptitude test, and when I got the results back, it listed careers that might be you might fit your aptitude, and mechanical engineering was on the list. And I thought, hey, that sounds interesting. I'm gonna go do that. So I didn't really know what it was though, but that's how I got involved in it. I went to the University of Dayton to get my mechanical engineering degree. That's a small private school in Ohio that has some pretty strong ties to the Air Force, through Wright-Patterson Air Force Base, and GE, because GE makes jet engines down in Cincinnati. One thing I wanted to put on here and just recommend for those of you that go in engineering, if you want to get a professional engineer's license at some point in your career, it's a good idea to take the fundamentals exam, and maybe you've heard it called the engineer in training exam. It's a good idea to take that exam while you're still in college. And I took it when I was a senior. It's an 8-hour test you take, but if you pass that exam, it's like a prerequisite to get your professional engineering's license someday. So that's something I would just suggest. If that's a path you think you want to take, you want to think about doing that in school. The last 2 years of college, I did intern at the local power company, and that was Dayton Power and Light. And I worked in a power plant as an intern, and that's where I really got my interest in that type of equipment, the machinery that's involved in power plants, and just how we harness that energy. So when I did graduate, I got hired on with that company that I had interned with. And to get your professional engineer's license, after you graduate from school, you have to be working for 4 years before you can get accepted to the engineer's exam, and you have to get some recommendations from other people who are already professional engineers. And it's an 8-hour exam that you take. And you know, I highly recommend pursuing an engineer license, even if you decide that you're not going to design as a career, which I don't design. You may have people that work for you, either directly or that you contract that have to be licensed engineers. And you know, when you obtain a license like this, they understand that you're on the same equivalent as far as your aptitude, so to speak, that you understand what's required from a design standpoint, and it gives you a little bit of respect, even if you're not doing design work. Another thing I just mentioned is that oftentimes when you go through engineering, you have to make a decision whether you're going to really stay on the pure technical path and primarily be focused on project design type work, or if you want to get work down a management track, which is where I decided I wanted to go. So while I was going, after I got out of engineering, I started going night school when I was working, and I worked towards getting my MBA. And so that's just something I would mention to you. It's something that you have to look at before you, as far as a career path. Do you really want to stay the technical path, or are you more interested in having that technical aptitude and being going into project management or business unit management? Now this is where I try to tell you how exciting the power industry is, okay? Dominion hires hundreds of engineers. We have hundreds of engineers at Dominion in our corporate offices, in all the power plants, really in all the offices in Dominion. We have engineers of some sort of another. And I've listed all the type here that I could think of that I know that I've worked with or work around. And obviously mechanical is the best, but we do have these other guys that hang around and other things. But at Dominion, you know, designing and engineering new components and systems, that's part of their jobs. In the plants, a lot of that is really troubleshooting and fixing existing components and systems. A lot of our plants were built many years ago, so there's a lot of retrofit type work we do, and we upgrade our systems to the latest state-of-the-art type equipment. Another real important type of work that engineers do at Dominion is failure analysis, and I put RCA there. That stands for root cause analysis. That's very important for us to understand when something actually does fail in service, why it did that, how to prevent it in the future. And oftentimes we have many types of this piece of equipment throughout our system, so to understand why it failed will help make sure that we don't have similar failures at other locations. Performance testing is a big thing if you're a plant engineer, in terms of making sure the plant's operating the way it should, and then project management. Now a little bit about the future of the power industry, because it's changing quite a bit. Coal-based power is diminishing, and that's, I think you probably all know, just due to environmental regulations, and even the fact that we've discovered a lot more gas in the United States, the abundance of gas in the shale, the Marcellus Shale region around Ohio, Pennsylvania, those areas. That they believe now we have 100+ years of natural gas available to us through fracking. Based on environmental regulations and based on the gas availability, that's causing coal plants, especially older coal plants, to shut down. And it's very hard to build a new coal plant right now. It's almost impossible at this time. But as those plants diminish, it's these natural gas plants that are becoming predominant, and Dominion is very active right now building natural gas plants. And the renewable energy is gaining market share, and that's what I list here for renewables: biomass, hydro, wind, and solar. From a natural gas perspective, this is a model of a GE gas turbine engine, and we have a lot of these engines that are burning gas to produce electricity. And I just put down there some facts there because a lot of people don't understand what these engines are, but you know what a jet engine is, you know what a jet engine does. A gas turbine engine is a jet engine, but it was not built to fly, it was built to produce power, so it's much more, it's an industrial type engine, okay, and it weighs a lot more, it produces a lot more power. As I said here, it produces, this engine that I show here produces 20 times the power of a 747 jet engine. And I just mentioned that 600,000 plus horsepower, so there's a lot of, this engine's producing a lot of power. And but this type of engine is really what's being used across the country because it's the most efficient In a combined cycle application, it's the most efficient way to produce power using fossil fuels. Biomass is becoming more prevalent, and I have 4 biomass stations now. It's, you know, what I'll say about biomass, a lot of people don't think of biomass as being renewable like wind or solar, because you are harvesting a product and you're burning the wood. But the wood that's used for biomass is all wood that's being timbered for the industry, the paper mills and the lumber mills, you know, for the products that they're already making. And the waste product from that process, the bark, the branches, any of the wood that they would leave behind that they don't use for their products, are what come to biomass plants to be burned and generate power. And the wood product is actually is much cleaner fuel than burning coal. And there's always a lot of concern about, well, if we burn all this wood, you know, is that going to be a problem? Are we going to lose all our forests? And I just put a little note down there because most people don't realize we actually have, you know, more acres of forest today than we did 20 years ago. And this industry, the wood industry, has been around for a long time. These forests get harvested, but they also get replanted, and they rotate these forests that they actually use in the process. Hydro is another, you know, so to speak, free source of energy, and what I showed here, and it's not a very good picture, but pump storage is something that Dominion has, and some other power companies have. But it's one of the most efficient means of storing power. And you know, storing power is not something you can really do, electrical power, but we can do it in this sense that we have a lake at one elevation, and maybe you know, in well, it's at a higher elevation, and we have a lake at a lower elevation, and we allow the water through our pipes to drain from the upper lake reservoir down to the lower lake, and we use that power from the water coming through that pipe to generate power. And we do that during peak days when everybody needs their energy. And then at night, when power is inexpensive, we take that generator that was producing power during the daytime, and we turn it into a motor. We motor it, and we pump the water back up through the same turbine up to the upper reservoir. So it's just a matter of moving the water back and forth. So it's, you know, from that standpoint, it's a free source of power. And it's the only way we can store large amounts of power. Of course, wind's becoming more prevalent. It is clean, it's free energy. Dominion does own wind turbines, not in Virginia, but we have them in other states. And some of you may know that we own the rights to the area off the eastern coast of Virginia to develop wind power someday in the future. And the thing about wind power, obviously, as I said, it's clean and free, but I mentioned here that the power density and availability are low. What I'm saying there is that to get the same amount of power from wind turbines, like the engine I showed you earlier, that 600,000 horsepower engine, and the energy it produces, you would need 60 of these turbines to be equivalent to one of those engines I showed you earlier on. So from a power density standpoint, these take up a lot of real estate in order to get the kind of power you need. And availability is low because when you need the power the most in the summertime is when the wind blows the least. So, you know, the whole United States has been mapped. Everybody knows already where the best places are to place wind turbines, but those also aren't the best places to get power to people because generally they're not close to where people live. So those are some of the challenges we have with wind. But there is a lot of wind power, a lot of wind turbines out there. I know that GE has 20,000 wind turbines in the world, and I don't even know about the other manufacturers. So there is a lot of wind turbines being developed, and it's a good mix of the power. And the last one here is solar. Again, clean and free, and it has the same issues that wind has in the respect that you need a lot of land to get the power you need off of solar. And of course, when it's a cloudy day or it's nighttime, you're not getting any production for it. And the challenge for that power industry is that we have an obligation to provide power all the time. So we can't just build wind turbines and tell people, hey, I can't send you power today because the wind's not blowing, right? So even if we build a wind turbine, we have to have another type of generation in the background that can be there to supply power if that wind turbine or if that solar panel isn't available. So that's the dilemma for the power industry. We can't just build solar and wind without having other types of generation available. All right, so what is the connection between robotics that you do and power industry? And really I'm saying everything you all do here directly correlates to the power industry. The engineering design you do for your robots, the business acumen, the team itself is like a small business. You got to get revenue in, you have expenses for your team, you market your team, there's a whole range of things there. Obviously you have a project here you're trying to manage in this 6 weeks. You have to work together as a team, and chairman's, the presentation skills you have to have. These are all things that directly relate to what you need to be able to do in a real career. Oh yeah, and all the smart, good-looking people are doing it. Forgot about that. So just a couple last things I wanted to say. Who can tell me what that is?
It's an electrical board.
Yeah, but it's the what? Well, it is, but what else is it? The C-Rio? That's a C-Rio. So you guys control everything about your robot with the C-Rio and your control. In the power industry, these are pictures that are actually from the control system that controlled that engine I showed you at the front. And in the upper left picture, those are basically three C-Rios for a generating unit. And why would we have three? You have one to control your robot. We have three because we measure when we're generating power. Many of the things we have to monitor, whether it's electrical properties like voltage or current, or it's things like pressure or temperature. We don't just measure it one time. We will measure it with 3 devices, redundant devices for critical things that we have to measure. Each of those field devices, let's say it's measuring pressure. Each of those 3 pressure sensors goes back to its own processor, its own C-Rio. And when the control system's doing what it does, running its program, controlling that piece of equipment, it sees all 3 of those devices. If one of those devices in the field goes bad, you still want to be able to control your equipment, but the 3 processors are looking at each other and they're voting. They say, well, as long as 2 of these 3 signals are good, I'm safe to keep running. But if 2 out of 3 signals say, I've got a problem, then your program that's in the system is going to take some kind of action. It's going to reduce load on the machine, it's going to take the machine offline, whatever. But it's part of the logic of this control system to protect your equipment. And the picture on the top right, you think of your outputs from your board that go to your motors and tell your motors to run and when to run, or tell your compressor to come on and off. That picture on the top right, that's all the wiring that's going out to the field to tell the machine, to tell it to start something, stop something. It's also the signals coming back in that says I'm running, I'm not running, those kind of things. So everything you do from that standpoint is magnified in terms of how we control things in the power industry. What's that? Sim. That's a half horsepower motor. You guys use a lot of them to do a lot of different things. And in the power industry, our sims are a little bit bigger. They're about 3,000 horsepower. And that would be a typical motor in a power plant. Of course, we have other sizes, but just from a correlation perspective, same things you do here to control a motor, we've got to do in our power plants to control these motors, start and stop them. What's that?
Gearbox.
Yeah, gearbox, right? So we have a lot of gearboxes. Ours are this little bigger. This happens to be a gearbox that's on a steam turbine. It's geared to a pump, and these gears are about 12 inches in diameter and going about 6,000 RPM. So in this case, we had it opened up so we could look at the gears. It was inspection. Anytime you have a piece of equipment that's running at that type of speed, you have to have a regular inspection frequency. You got to check those gears, make sure you don't have cracks in them. That's part of what an engineer would do, and also make sure that you don't have clash with your gears and that they're meshing correctly. So, again, just another correlation. You guys use gearbox for different things, and in the power industry, we use gearboxes for all types of things as well. And that's all I really had today. So, anybody have any questions for me? Yes, sir.
How tall are generally your wind turbines?
How tall are they? I don't know the exact, I really don't know the exact height, Jordan. I don't deal with them directly, but they're you know, they're pretty far up there. They're a couple hundred feet or so. Yes?
Is there any, I mean, the tides always seem to be moving back and forth. Is there any type of tidal power capabilities?
Yeah.
Power generation?
Yeah, I don't know any of it in the U.S. In different parts of Europe, they have some tidal generation, and it's done several different ways. But one way is, yeah, the waves will move a damper of some sort, and and you would have air that damper compresses essentially, and that compressed air will then go through a device to generate power. That's one way of doing it. There's other ways too, but yeah, they do use tidal power generators.
Is coal and oil, is that all stuff that running out? I mean, do we have to move to this thing for that reason, or is it?
No, there's a lot of coal reserves, and of course, we're finding more oil now than we thought we had, because part of gas development is usually oil that comes with it as well. So those aren't limiting factors. It really comes down to air pollution regulations and clean power. And with as much gas as they found, or they think they have found, the price of gas has just dropped so low that coal can't compete with it either, generally. All right.
Thank you.
Thank you.
Mr. Brayton is always here, so if you have any questions after